Hypothesis is used in research and analytics to understand the relationship between dependent and independent variables. Hypothesis building can begin in the data exploration stage, but it becomes more mature and perfect in the conclusion and predict phase. Hypotheses are testable explanations of a problem or observation. Formulating a hypothesis is used for both quantitative and qualitative analysis to address a research problem. Hypotheses that suggest a causal relationship involve at least one independent and dependent variable. In other words, one variable which is presumed to affect the other. For example, holiday season in the year increases traffic and purchases on the website. An independent variable is one whose value is manipulated by the researcher or data scientist. A dependent variable is a variable whose values are presumed to change as a result of the changes in the independent variable. Let's now look at hypothesis building using feature engineering. Hypothesis building, a way to design models and predict the unknown, can be done using feature engineering. This includes identifying meaningful features based on data domain knowledge, automatically constructing new features from the raw data based on domain expertise, constructing new features manually from raw data based on domain expertise. Hypothesis building using a model has three phases. The first phase is model building, which comprises identifying the best input variables for the model, judging if the model can predict the outcome for the given input. The second phase is model evaluation. It's a phase in which you train and test the model, changing different parameters used in the model aiming for accuracy. This is also the phase where the performance is optimized for the following: model accuracy, model performance, model comparisons. The third phase is model deployment. In this phase, you have finished selecting the model you will use to solve the business problem. The output of the model will help you take better decisions through model prediction, model matching, or actual outcome meets the expectations. Population is a large data set, and samples are a part of it. A sample drawn from a population should have all the main attributes or features which represents the characteristics of the population. An ideal sample can be treated as the population itself, and the hypothesis outcome for a sample would hold true for the entire population. In the example displayed here, two samples are drawn from the population of a large dataset. Each sample has a mean. The process of calculating the difference between the means is known as hypothesis testing. Two kinds of hypothesis can be made initially. Alternative hypothesis. This hypothesis indicates that the proposed model outcome is accurate and fits the data. There is a difference between sample data S1 and S2. Null hypothesis. This hypothesis is the logical opposite of the alternative hypothesis and does not support the proposed model. It suggests that there is no difference between sample S1 and S2. The process of hypothesis testing begins by dividing a big dataset into training and test datasets, irrespective of the size of the dataset. This is one of the best techniques to design an accurate model. The training dataset is used to build a new proposed model. It makes use of the available features and responses of the data sample. The test dataset is used to test the proposed model. The test dataset acts as new unseen data. The null hypothesis that was formulated will be proven right when the proposed model does not predict better than the existing model. The alternative hypothesis will be proven right if the proposed model predicts better than the existing model. Typically, the training dataset size is anywhere between 60 and 80% of the big dataset, and the test dataset ranges between 20 and 40% of the big dataset.